if you want to test an online learner system, you can use any basically data set that is has a position of an object tracked. In particular, we played a lot and we used a lot in our laboratory the TLD tracking learning data set and detection, tracking learning detection data set by Eugenio Culurciello, which now has a company. Here is a link to the TLD dataset, and here are some examples. There's multiple examples with the fast moving object and so forth. And here is a paper by Eugenio Culurciello, which is basically one of the best tracking learning detection system out there at the moment. So if you want to test this algorithm, you basically use, for example, a video of a motorcycle, and you want to track this motorcycle or a panda bear or a pedestrian or a car moving around. You want to have a video, for example, that has multiple problems as occlusions, change in illumination and views and so forth. So you can test all possible different things. So as I showed before, the online learner has some problems. How can we solve these problems? Here are some possible solutions that we thought about in the last year or so. So first of all, we said, okay, we might have to try to segment the object so that we don't learn the background as much. This might help us, for example, with the auto-learn function when the classifier is learning something about the background and is drifting away. We also thought about removing the tracker and just using the convolutional neural network to track the object as well. We thought about adding a radial basis function layer so that we can add positive and maybe negative prototypes and curve them as we go. So this is just a slightly more powerful version of the distance metric that we were using in the online learner. So if you recall, we had this distance metric at the output of the classifier to match it to a prototype, and it might be too rough. So we thought about adding a radial basis function, which is a Gaussian spread parameters around centered on that prototype. Finally, if nothing else works, we might have to just improve the convolutional neural network classifier to do all of these things. So let's go in details and see a few of these issues. We'll start with the segmenting an object. Why is this a good or a bad idea? So the idea was, okay, why don't we learn, for example, the prototype, try to have it segmented before we try to recognize it. I mean, this is something that might be possible sometimes. Sometimes you just have a video or you have a scenario when you cannot really segment the object from the background, and it's usually the typical case. So this might look like maybe a silly idea to begin with, but it's something that it was worth checking. So if we learn an object without a background, basically the convolutional neural network then might not have enough power capabilities to learn that specific object with the background. Maybe because the background confuses it. Also, this particular example, the hand might be a fairly tough example, but because of the lack of distinctive features that it can have. As we've seen before, the hand recognition could be tougher than a face recognition. So in this case, we have a false negative. And then we also have a lot of false positive, even if we change the threshold. So this is definitely not a good idea. As we saw before, it's really not a good idea. Classifier has to do this with the background. So you need to have a vision system that can classify and segment the object at the same time. There's just no way around this. If we want to try to use the convolutional neural network to try the object, that is possible, and that's something that a convolutional neural network or a good classifier or a deep network should be able to do, as we talked about in the lecture about vision systems. So the convolutional neural network, for example, without the patch updates, uses only the first patches, is good for a variety of scenario, but for example, in the TLD data set, in the case of David, in the case of the David movie, the very first frame is quite dark, and so it's not really good. You also, the object might change shape quite a bit, and you might want to have a way to really update the patch. So some of the data set that we use in TLD also can contain a lot of noise, for example, the Panda data sets. But the CNN tracker without patch update, from what we can see, was probably the best that our system currently could do. With patch update, the tracker drifts. There's a shifting problems. As we've seen before, is basically the tracker starts learning more and more of the background, and eventually he locks on some background. So the problem of this is that the CNN, the convolutional neural network, is really not good enough to track, so he's losing the object different times, and we need to improve this. We'll see later ideas or how we could do that.